All right, let's dive deep into muscles. You've been doing some serious research, it seems.
Yeah, lecture notes, diagrams, you've got it all laid out.
Ready to flex that knowledge even further.
Absolutely.
Awesome. We're not just talking bicep curls and squats here.
Right.
It's way more than that.
It really is. Muscle function impacts everything from how you express yourself.
Yeah, to like those amazing athletic feats.
Exactly.
There's over 600 muscles working behind the scenes.
It's wild.
And they make up a huge part of our body weight.
About half.
Yeah, half. Today, we're going beyond just naming muscles.
Okay.
We're going to uncover how they're organized.
The structure.
Yeah, how they work together.
It's fascinating.
And why some people excel at powerlifting while others dominate marathons.
That's a great point. And that's where muscle fiber types come in.
Okay, break that down for me.
You've got your marathon runners built for endurance with slow twitch fiber.
Mm-hmm.
And then you've got your power lifters, those explosive fast twitch fibers.
Okay, so it's not just about the size of the muscle.
No, not at all.
It's about the type of fiber.
Exactly. It's all about those fibers.
That's really interesting. I'm looking at this diagram of muscle organization, and it kind of looks like a roadmap of a city.
I can see that. Think of each muscle fiber as a single player on a team,
Okay,
grouped together in specific formations.
gotcha.
And these formations, or muscle types, determine the muscle's strength and direction of pull.
So just like sports teams have different strategies,
Precisely.
our muscles have a specific organization for what they need to do.
Exactly. We've got 5 main types: fusiform, parallel, convergent, pennate, and circular.
5.
Each one has its own strength.
Literally.
Haha, yeah, literally. And they all have a different range of motion.
Okay, so can you give us some real-life examples of these muscle types?
Absolutely. The biceps brachii, the one everyone loves to show off.
The classic bicep flex.
Exactly. It's a fusiform muscle,
Okay.
thick in the middle, tapered at the ends. It's built for both power and speed.
Interesting. This reminds me of when I pulled my hamstring.
Oh, yeah.
I was amazed by how much that one injury affected my walking.
It shows how important the position of a muscle is to its function.
Yeah, it really does.
It all comes down to where muscles attach to bones at points called origins and insertions.
Okay.
The origin is usually the more stationary anchor.
It was like the base.
Yes, exactly. While the insertion is the part that moves.
During the contraction.
You got it.
So when I contract my bicep, the insertion point on my forearm is pulled towards the origin point on my upper arm.
Yes, and that bends your elbow.
It all makes sense now.
But it's not a solo act. Muscles work in teams for smooth movements.
They do.
They have to. We have the prime movers, the stars,
Okay.
the synergists who assist them.
The backup dancers.
Exactly. The antagonists who oppose the motion for control.
Okay.
And the fixators who provide stability.
So wait a minute.
Yeah.
I can strengthen my muscles without even moving.
You can. It's called isometric contractions. Think of holding a plank.
Oh, okay.
Your muscles are engaged but not changing length.
It's burning, but I'm not moving.
Exactly.
Wow. There's so much more to muscle strength than just lifting weights.
There really is.
So tell me more about these muscle teams and their roles.
Okay, let's break it down with the bicep curl. The biceps brachii is the prime mover.
The star.
Yes. The brachialis muscle assists as a synergist.
So like a helper muscle.
Exactly. And the triceps on the back of your arm, they're the antagonist.
So they're relaxing while the bicep is working.
Yes, to allow that bending.
And what about the fixators?
Muscles like the rhomboids in your back, they keep your shoulder blades stable.
So it's like a whole team effort.
It really is. It's happening all the time throughout your body, whether you realize it or not.
This is amazing. It makes me think about how different exercises affect our muscles in different ways.
That's a great point.
I know strength training builds muscle, but I'm curious how that happens on a microscopic level.
Yeah, let's zoom in on that.
Let's do it.
All right. So imagine each muscle fiber as a bundle of these tiny protein threads called myofilaments.
Like little strings.
Yeah, kind of. They're organized into these repeating units called sarcomeres.
Sarcomeres.
Yep, they're like the building blocks of muscle contraction.
So each sarcomere is like a mini powerhouse within the muscle fiber.
Exactly. And inside each sarcomere, you have 2 main types of myofilaments.
Okay, what are they?
You've got actin,
Actin.
the thinner one,
Mm-hmm.
and myosin.
Myosin.
That's the thicker one, and it has these little heads that can grab onto actin.
Okay, so like tiny little hands.
Yeah. It's all thanks to something called the sliding filament theory.
Sliding filament theory, what's that?
It's basically a microscopic dance that makes muscles contract.
Okay.
So when your brain tells you to move,
Uh-huh.
calcium ions flood the muscle fibers,
Interesting.
and this lets those myosin heads latch onto actin.
Like they're connecting.
Yeah, and then the myosin heads pull, drawing those actin filaments closer together.
So it's like a tiny tug of war happening inside the muscle.
Exactly. That's a great way to put it. The myosin pulls the actin, the sarcomere shortens.
And that makes the whole muscle contract.
You got it. And when thousands of those sarcomeres are shortening all at once,
Whoa.
that's how your muscle generates force for movement.
That's so cool. So does that mean the more sarcomeres are firing, the stronger the contraction is?
Exactly. The force depends on how many muscle fibers are activated.
Makes sense.
How often those nerve signals fire, even the muscle's length.
The length matters.
Yeah, there's this sweet spot where the muscle can generate the most force.
Okay.
If it's too stretched out or too scrunched up, it loses power.
It's like the muscle needs to be in the right position.
Exactly. It's like a Goldilocks scenario, not too long, not too short, just right.
That's a great analogy. Now, I hear people talking about isometric and isotonic contractions,
Yeah.
but I always get them mixed up.
Sure, I can explain those.
What's the difference?
Well, isometric contractions, we talked about those earlier with the plank example. Right.
The muscle is working, but not changing length.
Like trying to push a car that's stuck.
That's a good one. You're putting in effort, but there's no movement.
Makes sense.
Isotonic contractions are the ones where you see movement.
Okay.
There's two types, concentric and eccentric.
Concentric and eccentric, okay.
With concentric, the muscle shortens as it generates force.
Okay.
Think about curling a dumbbell.
So the bicep is shortening as I lift it.
Yes. That's concentric.
What about eccentric?
Those are the negative reps you hear people talk about.
Oh.
The muscle lengthens while it's still under tension?
So I'm still using my muscle even though I'm lowering the weight.
Exactly. It's like the braking system for your muscles.
Interesting.
It controls the speed of the movement, and it helps prevent injuries.
That's really important.
It is.
So it's all connected. This is making me think about how different types of workouts affect our muscles.
Yeah.
Like strength training versus endurance training.
Right.
So I know lifting weights builds muscle.
But how does that actually happen on a microscopic level?
So when you lift weights, you're actually creating tiny tears in those muscle fibers.
That sounds bad.
It's not. It's actually what makes them grow.
Oh, okay.
Those micro tears signal your body to repair and rebuild the muscle.
So my muscles are basically saying, hey, we need to be stronger to handle this.
Exactly. It's amazing, right? During recovery, your body fixes those tears and adds more protein filaments.
And that makes the muscle bigger and stronger.
Yes. Now, endurance training, like running, it's more about enhancing your cardiovascular system and how well your muscles use oxygen.
So it's about stamina.
Yeah. You're training those muscles to be lean, mean, energy-producing machines.
Makes sense why marathon runners don't look like bodybuilders.
Exactly. They're training for different things.
So cool. This whole deep dive is really showing me how our bodies adapt.
It's incredible how interconnected everything is.
It really is. Speaking of interconnectedness,
Yeah.
how does the muscular system work with other systems in the body?
That's a great question. Well, it's like a whole team effort.
A team effort.
Yeah, with different systems.
Okay.
You've got the muscular system working with the skeletal system for movement,
Makes sense.
the nervous system to send signals and coordinate contractions.
Oh, so that's how our brain tells our muscles what to do.
Right. And the cardiovascular system to deliver all the oxygen and nutrients.
So it's like a network. They all rely on each other.
Exactly.
This is really making me see that taking care of our muscles isn't just about looking good.
Yeah.
It's important for our overall health.
Absolutely. It's crucial.
But, as we age, don't our muscles naturally lose strength?
Yeah, unfortunately, that's true. It's a process called sarcopenia.
Sarcopenia.
Yeah, it's basically age-related muscle loss.
So it's like a reminder that taking care of our muscles is a lifelong thing.
It really is. We can't stop the clock completely,
Yeah.
but we can definitely slow it down. Exercise, especially strength training.
So lifting weights isn't just for young people.
No, not at all. It's like a fountain of youth for your muscles.
That's a great way to put it. What about nutrition?
Nutrition is key too. Muscles need protein to repair and rebuild.
Right, because protein is like the building blocks for muscles.
It is. You also want to make sure you're getting enough vitamin D.
Vitamin D, what does that do?
It's crucial for muscle function.
Oh, okay.
And something called creatine can help with strength and power.
Creatine, okay. I've heard of that.
It's like a support team for your muscles.
So protein is the star player,
Yeah,
and then vitamin D and creatine are like the essential crew members.
exactly.
Now, I'm curious about muscle injuries.
Okay.
I feel like strains and tears are pretty common, especially if you're working out a lot.
Yeah, that's true.
Any tips for preventing those?
Well, first of all, always warm up before exercising.
Yeah, that's important.
It's like preparing your muscles for what's coming.
Okay.
Regular stretching is important
That's
too.
okay, yeah.
It makes your muscles more flexible and less likely to get injured.
But sometimes it's tempting to push through pain when you're working out.
Oh, yeah, I know that feeling.
Is that ever a good idea?
Not really. You gotta listen to your body.
If it hurts, stop.
Exactly. If you feel sharp pain, that's your body telling you to rest.
Okay.
Ignoring it can lead to worse injuries.
That makes sense.
It's all about finding that balance between pushing yourself and knowing your limits.
So it seems like the more we know about our muscles,
Yeah,
the better we can take care of them.
absolutely. Knowledge is power when it comes to your health.
Wow, this deep dive has really changed how I think about muscles.
Me too.
They're not just about strength.
Right.
They're essential for everything.
Well said. Strong muscles mean a strong body and a strong mind.
And that allows us to live our lives to the fullest.
Exactly.
Well, I think that about wraps up our deep dive into the world of muscles.
I think so too.
We've learned so much about their structure, their function, how they adapt to exercise, and how vital they are for our well-being.
It's been a great journey.
It has. It's amazing how complex the human body is.
It really is. And we're still learning new things all the time.
That's the exciting part. We hope this has inspired you to learn even more about your own body and how to keep it healthy and strong.
Thanks for joining us.
See you next time.